Hello, my name is Toro Grapel and I'm going to show you our Inferno one-click inference in Excel demo. The idea behind Inferno is to make machine learning accessible to everyone, even to people who may not know what it is. The basic UI metaphor that we're going to use is that of an incomplete table. For example, here you see an incomplete table where the left column represents the chirp frequency of cicadas and the right column represents the outside temperature. As you can see here in the blue dots in this plot, these two variables are positively correlated. That means the warmer it is outside, the higher the chirp frequency of the cicadas. Now here in this table we also have some missing cells, here of the outside temperature and for these here of the chirp frequency of the cicadas. Here's where Inferno comes into play. We take a user-defined function called Inferno, which takes as an input the table on the left-hand side here, and which maps that to this region on the right-hand side. You can see here the function Inferno, and what it does is it takes the table and completes it. This area here, which is empty in the left-hand table, is filled with the best guess of the algorithm on the right hand side, and similarly for this empty region here, which gets completed here. The results you can see in this plot here. You see that the green line and the red line are very good approximations of the blue cloud of points that constitutes the original data. But we can also look at more detailed information of what the algorithm produces. For example, if I put dist here for distribution, then instead of just giving us the mode of the distribution, we obtain the so-called predictive distribution, which in this case is a Gaussian with a certain mean and a certain variance. So we also get information about the confidence of the algorithm. We can also get information about how plausible the observed values are. We call that p-value here. And you can see here cells that get a very low value assigned, for example 0.1, will be less plausible values, whereas cells that get higher values like 0.5 or 0.6 assigned, those will be plausible values, and this can be used to identify outliers. Now let's move on to another example, in this case a recommender system. This could, for example, be very useful for someone who runs a small business and who has some information about their customers and would like to find out which products to recommend to these customers next. Here's our incomplete table again. The rows represent the customers and the columns represent the products that a user might want to buy. In this case, the dataset is a very old recommendation dataset where the users are users of a website, and the columns represent jokes, and the users gave ratings using a slider to each of the jokes they were shown, and these ratings are from -10 to 10. You can see them here. For example, this cell here represents the rating that user 1 gave to about joke 3, which apparently he didn't like because he gave a very negative rating here. Green corresponds to positive ratings, red corresponds to negative ratings. And now we use the exact same function Inferno to map this incomplete table here to a complete table on the right hand side. You can see here again the missing values, for example for user 3 here, have been filled in with guesses of the algorithm based on the surrounding data. And in this case you can, for example, see that for this pair of values, the left number here was predicted to be relatively negative with -7 something, where it is missing here, and the reason might be that there are other examples of users that saw both jokes and found both of them not so good. As a consequence, these are correlated, and hence this prediction can be made by the algorithm. But of course this system would now enable a business person who wants to recommend things to their customers to build a very simple recommender system in Excel and figure out what they should recommend to their customers. So the next example, binary classification, shows how the Inferno approach really takes up the idea of supervised learning in the area of machine learning. The example comes from a medical domain. Each row here represents a patient, or a patient sample rather. These features are features that describe a tumor found in the tissue, and these could be things like the diameter of the tumor or the circumference and so on. And in addition, we have a label here, M, where M stands for malignant and B stands for benign. So this is a diagnosis task. And we have all this data, and the task is to learn from this data how to predict from these features, of which we have 30 in total here, to predict if it's a malignant or a benign kind of tumor. And in order to test the system, what I've done here is, if we go down all the way here, I've removed the labels from the data set here for the last 100 examples, and I've copied them over here so that we will be able to compare to them in a moment. And so these are basically the test cases on which we want to test the algorithm. So now we do what we did before. We apply Inferno to the entire left-hand part of the table here and map that to a new table, including the label column. You can see here that it is again the same Inferno function that we had been using before. And all of this is data that was provided except for these values here. These were the missing values on the left-hand side table, and they have now been filled in by the algorithm. You can see that there is very good correspondence between the predicted labels and the actually observed labels. Every now and then there is a discrepancy because, of course, the problem is noisy and no machine learning algorithm could do perfectly under those circumstances. So then here what we have is that someone could use Excel to build a simple diagnosis support system in a medical domain or in other domains. So far we had mixed data here with double values or floating point values in these cells here and binary labels here. Now let's look at a purely binary problem. What we have here in this data set is rows are congressmen in the year 1984, and columns are certain bills they voted on. And we also have a column that indicates which party they belong to. Here we have Democrats, and then further down we'll also have Republicans. And now, as one would imagine, the voting patterns correspond in some sense to the party affiliation. And we can now take, again, this whole table here and map that using the Inferno UDF to the right-hand side. And you see again the same function, Inferno, that maps this whole table to this table, and the missing bits are filled in. So you see that this Congressman 1 would have voted no on this bill number 1, although he didn't actually show up. And so the missing cells are filled in by the algorithm again. Finally, I would like to show you an example where we have a very mixed bag of variables. This is a data set where the rows correspond to car models, and the columns are certain features of the cars, for example, miles per gallon, the number of cylinders, as a discrete feature here, the displacement, horsepower, even the origin here, US, Asia, or Europe. And what I've done here is I've copied a little bit of this data over here, and I've removed some of the cells. Observe that this cell is missing, this cell is missing, this cell is missing, this cell is missing, and so on. And what we can do now is, and I want to show you a different UI metaphor here, is we can directly mark this bit of the table, or in fact any other bit of the table, go to add-ins, choose a model and press Inferno autocomplete. And what happens here is that we now see that the missing values have been filled in. The missing ones are the ones that appear in light blue here. You can see that the model predicted correctly that this is an 8-cylinder, this is an 8-cylinder, that this is a US car, maybe because the mileage is so poor, that this is a European, that this is another US car. And what we also see is that there are, oh, this is actually a mistake here. So here the algorithm made a prediction error. We also see that some of the cells are colored in orange or in red, and these are outliers, so these are non-typical values that the algorithm is flagging. And this could be very useful for users because these could either be genuine mistakes where maybe the data entry has failed and there is a real error in the data, which would be interesting to know, or they might just be extreme or interesting cases in the data, which would also be very interesting for a user to know. Furthermore, we can also visualize the detailed results of the model, but this may not always be desirable because we would like to leave the system as simple as possible. So what you saw here is really one-click inference in Excel as done by our Inferno system. Thank you very much.